GraphQL is a popular language for querying and modifying data sources via APIs. It was developed by Facebook, but since 2018 has been overseen by its own foundation. GraphQL interfaces are an increasingly common way for systems to share data over APIs, in large part because of the flexibility in how you define these APIs. It's not unusual for the same data source to provide multiple GraphQL interfaces to offer a choice of views of the data. Release 11 of the GraphDB RDF Knowledge Graph Database Manager makes it easy to create one or more GraphQL endpoints to provide this kind of API access to a GraphDB repository. You can send GraphQL queries to these endpoints, and if you have the right permissions, you can send GraphQL mutations that add to, edit, and delete data in the repository. These capabilities provide a lot of new opportunities for how GraphDB can support other systems that play roles in a large, complex application. When we create a new GraphQL endpoint for a GraphDB repository, there are two approaches we can take. For the GraphQL schema shapes approach, you build on a GraphQL schema shapes model that describes your data structures with a GraphQL model. This model uses the GraphQL data shapes vocabulary to specify the high-level structure, and you can then use Shackle, RDFS, and OWL to specify details about which types and fields to make available via the API. This method is best when you want to have more control over the GraphQL schema that gets generated. We'll see more details on how to do this shortly. With the OWL ontology's Shackle Shapes approach, you identify existing RDFS schemas, OWL ontologies, and Shackle Shapes to use as input for GraphDB's API generator. This method is best when you want to quickly generate a GraphQL schema from models that you already have. I'm going to use the first approach to create a GraphQL endpoint in a new repository. Here is an RDFS schema for data about some company employees. Each has a family name, a given name, a start date, and an address. The employee's address is an instance of the address class, and each one has a city and street value. Below that, we see some sample data that follows the structure of the schema. 3 people, 2 of who have addresses. The other file that we'll be importing uses the data shapes GraphQL vocabulary to create an instance of a GraphQL schema that has shapes for each of the 2 classes from the RDFS schema that we saw earlier, an employee shape and an address shape. The actual shapes are standard Shackle, showing the class's properties and their data types. Like we saw in the RDFS schema, the value of an employee's address is not a value of some data type, like a string or a number, but an instance of the address class. I'm going to create a new GraphDB repository called Employees. And I'm going to make it the active repository. And then I will import the 2 data files that we just looked at to be that repository's contents. This is a regular GraphDB repository, and we could do Sparkle queries and talk to your graph and all the other GraphDB features with it. I'm going to create a GraphQL endpoint for this repository by picking GraphQL from the main menu, then Endpoint Management and New Endpoint. Earlier, I mentioned the 2 approaches to creating GraphQL endpoints in GraphDB. For this demonstration, we'll use the first one, which is already selected. When this is selected, the screen lists the GraphQL schema shapes in this repository, and we see the employee GraphQL schema that was declared in one of the files that we imported earlier. It's available, so I'll select it to add to the Included for Generation list. After I click the Next button, you can see various ways to customize the endpoint, but I'm going to stick with the default settings, and then click the Create Endpoint button. And we're done. To try it out, we can go to the GraphQL playground, where we can enter GraphQL queries by hand or use the built-in graphical explorer to create the queries. Instead of using this built-in tool, though, I'm going to try out my new GraphQL endpoint using a different tool called Postman. Postman is a popular platform for designing, building, and testing APIs. It's been around for 13 years. As far as I know, its developers have had no knowledge of GraphDB, but it is very popular with developers working with GraphQL, so let's see how it does with the GraphQL endpoint that we just created on a GraphDB server. We'll pick New, then GraphQL, to show that we want to connect to a GraphQL endpoint. It wants us to enter the endpoint's URL. GraphDB's REST API documentation shows us a few forms that this endpoint URL can take. Once we insert the name of the repository, so I'll take the simplest one and add the hostname and port number at the beginning, and then paste it into Postman's URL field. In addition to the hostname and port number, you can see that I also added the repository name employees to the appropriate place in the URL. As soon as I pasted it, Postman did a background query for the schema of the API at that URL, and then displays the schema where I can select classes and fields to build a query. I want to query for the employee address cities, given names, and start dates. But I only want employees who started after February 1st, 2024. As I filled query details out on the left, you could see the query being assembled on the right. When I click the blue button to run the query, in the response section below, we can see the 2 employees who met this condition. When I created this GraphQL API endpoint, I accepted the default values for a lot of potential settings. But if you take a look at them, you'll see many ways to customize the API that you create. You could learn all about them in the GraphDB documentation. You can download GraphDB and a free license and try all this out yourself, along with all the other features that make GraphDB such an ideal platform for building and using scalable, standards-based knowledge graphs.